Welcome all of you to my video channel. Mainly, tutorial videos are included in this channel. The tutorial on electrical panel and maintenance contain videos that will give more knowledge to those who want to know about electrical panels. As part of fire and smoke control, there are videos explaining fire and safety, smoke management system and smoke control system. Other videos from this video channel are easy to do home electrical work, educational videos, and descriptions of books, blogs, travel and culture. Also includes a basic description of electronics and the design and construction of a printed circuit board. Thank you for watching my videos. Subscribe to the channel to get more videos and updates. Know about electrical panel and maintenance. Electrical panel. Part 1. The purpose of this channel in particular for electrical technicians and also for those who wish to get knowledge about electrical circuit system. In this tutorial, we will provide a detailed study about the electrical panel, controls, components, repair, and maintenance. The electrical main panel is known as the main switchboard in the LV section. In general, the maximum current rating of a single MSB shall be 2500 A. Sub-main board is connected in between MSB and the distribution board to deliver the power to domestic equipment placed inside the building. Protected cables are using to connect between MSB and SMB to DB. Normal PV cables are using to connect from DB to all domestic equipment inside the building. Tutorial Part 1. Provide a study about MSB, SMB at DB. Schematic drawing and how it is important in the electrical circuit. In all buildings, a schematic diagram shall be available in the electrical room. Here describe the schematic diagram and how each section represents the building's power system, so we can start this tutorial with the schematic diagram. A schematic diagram is a representation of the elements of a system using symbols rather than the original diagram. The schematic is intended to convey the essential information of the system using simplified elements to get the meaning easier. A schematic usually removes all details that are not relevant to the key information. This is also known as a single-line diagram. Single-line schematic diagrams are often used for the maintenance and repairing of electronic and electrical systems. Schematic diagrams simplify and compress the details of the three-phase system, showing only one element instead of three lines. A single-line diagram is easier than a three-line to follow. Three-line diagram is also using as a schematic, but it is not common. Three pages of a three-line diagram shall be replaced with one-page simplified single-line diagram. Typical schematic of the electrical circuit system given in this drawing. Let us discuss each section in detail. Transformer. Step down the high voltage to low voltage. Power source. This shall be from generating station. This is a high voltage. Control system. This section describes the control section of the panel. Main circuit breaker. Normally this breaker shall be ACB. Sub-main distribution board. These boards are fixed inside the building. Power from the main panel connecting to SMB through circuit breakers. Final distribution board. Equipment using in the building connected to this board. The distribution board is connected from sub-main boards. Typical drawing with incomer and outgoing is shown in the layout. A typical bus bar layout is shown in the drawing. A typical SMB and DB layout is shown in the drawings. Three and single-phase voltage is given here with the drawing. Considered the three-phase voltage like 415 volts. Red, yellow, blue and black colors are using to indicate phase and neutral. Functions and use of the components used in the panels such as ACB, MCCB, MCB, ELCB, relay, timer, and contactors shall be provided in upcoming portions. Thank you for watching the tutorial. Subscribe to the channel to get updates and more videos. In the last part, we covered schematic drawings and a general study about MSB, SMB, and DB. Know that knowledge about schematic is very important in the field of maintenance and repairing of the electrical panel. Electrical panel part 2. Here providing some more explanation related to schematic diagram and electrical panel. Portions included in this part. Form of separation, Ingress Protection, electro-mechanical interlock and auto transfer switch. Form of separation is standardized in BSEN 60439 and IEC 60439 that provides instruction to the distribution of bus bars and breakers in the panel. The drawing refers to the key symbols to follow functional units and the panel. The pictures of the panel show the different models of form of separation. Form 1 no separation provided bus bar and functional unit. Form 2, main bus bars separated from the functional unit. Form 3, main bus bars and functional units separated each other. Form 4 bus bars, functional units, and bus bar terminals separated each other. Ingress Protection. IP indicated with 2 digits. The first digit indicated the protection against solids and second stand for protection against liquid. combination of 2 digits standardized in IEC 60529. IP00 means no protection. IP68 indicates full protection, 6 indicate protection from dust, and 8 denotes immersion in water up to 3 meters. IP rating provided depends on the requirement of the equipment and its area of use. The first digit of IP protection against solids. 0. No protection. 1. Protection against solids up to 50 mm size. 2. Protection against solids up to 12 mm size. 3. Protection against solids up to 2.5 mm size. 4. Protection against solids up to 1 mm size. 5. Protection against dust. 6. Complete protection from dust. The second digit of IP protection against liquids. 0. No protection. 1. Protection against direct falling water. 2. Protection against spraying the water in a 15-degree angle from the vertical. 3. Protection against water spray in a 60-degree angle from the vertical. 4. Protection against spray water from all directions. 5. Protection against low-pressure water jets from all directions. 6. Protection against strong jets of water from all directions. 7. Protection against the effect of immersion in the water up to 1 meter. 8. Protection against the effect of water immersion up to 3 meters. Electro-mechanical interlock. This type of interlocking is provided in the panels that require 2 different incomers, such as main power source and secondary power source. The main power source is from the normal electrical stream and the secondary shall be from the local power generator. The system is using the buildings where continuous power supply is required. In this condition, only one incomer ACB should be close at a time. Mechanical interlock is provided in between the main ACB or in the closing contactors of ACB for safe operation. The lock controls when one breaker is close, the other will be open. This locking system did not allow both breakers to be close at the same time, but it allows keeping open both breakers at the same time. Electrical interlock. This locking system provides in the control circuit of the incomer ACB. The power for the control circuit is distributing through 2 different control relays. Refer to the SLD provided here. The coil supply of relay K2 connected through the NC, normally close, of relay K1 and coil supply of relay K1 connected through NC of K2. Thus control circuit provides power to only one circuit to operate at a time. Relay K1 supplying to control mainstream incomer breaker and relay K2 for second incomer breaker. More details provided in the automatic mains failure control system. Auto transfer switch is using to deliver secondary power supply to the panels which have only a single incoming breaker. ATS is a separate section attached to the main panel. This unit has two different incomer sections and one common outgoing section to load. The typical design of the ATS system given in the SLD shows two power source, one output, and control. More details and functions of ATS included in Part 3. Thank you for watching the tutorial. Subscribe the channel to get updates and new videos. Electrical panel pad 3. Look back at the portions that we covered in the last two parts. Schematic diagrams and importance. Form of separation. Ingress protection. Electro-mechanical interlock. Auto transfer switch. Portions included in Part 3. Automatic transfer switch. Automatic mains failure system. Let us proceed from the previous part. The ATS panel is used to provide a secondary power supply to the MSB with only one incoming breaker. Three-line diagram and pictures of two types of ATS given here. The ATS panel has two incoming terminals and one outgoing terminal. Utility power and generator power connected to the ATS as Terminal 1 and Terminal 2, as shown in the diagram, and common output goes to MSB. The control circuit senses the main power received at input 1, and if any failure or change in power occurs, input 1 will open and send a signal to start the generator. When the power reaches the secondary side, the system closes the secondary contact and supplies power to the MSB. The transferring process will be completed within 6 to 8 seconds after a utility power failure. When the utility power is restored, the control system will check the stability of power. If the power supply is detected as correct, the system sends a signal to open the secondary contact, stop the generator and close the main breaker of ATS to deliver power to MSB. When the power arrives at MSB, the control circuit sends a command to close the incomer ACB. The transferring process will be completed within 10 seconds when the utility power restores. Automatic mains failure system. The AMF control system is used to provide a second power supply to panels that with two incoming sections or two incoming sections with bus coupler. AMF system controls the power supply of the MSB when the main power source fails. The logic of the control circuit used to transfer power described here with a single line drawing. MPFR, main power phase failure relay with under and over voltage protection. GPFR generator power phase failure relay with under and over voltage protection. Relay K1, power to the main incoming section control circuit. Relay K2, power to generator incoming section control circuit. Relay K3, auto manual control switch to circuit. Relay K4, off delay timer sends start signal to the generator. Last part, we learn about the electrical interlock. Here the same interlock is given and the other provided via PFR. In this logic, other interlock provided after NC of K2. If MPFR is not active, K1 will not close, and the same applies to K2 also through GPFR. Functions of PFR included in the controls part. Panel with 2 incoming power. The main power and generator power connected with phase failure relays. As soon as the MPFR realizes the failure of the main power source, the power supply to the primary side control stop. Followed by the main breaker open and the off timer send a signal to start the generator. Voltage from the generator reaches the control circuit, the GPFR detects the stability of the voltage and send a close signal to the relay K2. Then the control circuit send a signal to close the secondary side breaker and the panel works on generator power. The whole process will be completed in 6 to 8 seconds. When utility power is restored, the MPFR detects the stability of the voltage and signals the K1 to close. Then the secondary breaker opens and the generator receives a stop signal from K4. incoming breaker close and the full panel will go live within 10 seconds. Details and functions of all spares and relays will be included in the controls part. Automatic mains failure functions continued in part 4. Thank you for watching my videos. Subscribe to the channel to get more videos and updates. Electrical panel part 4. Automatic mains failure system. Continues from part 3. MSB with 2 incoming side and 1 bus coupler. This panel is divided into 2 sections such as non-essential and essential. The essential side supplies power to the areas where continuous power is required and the other section supplies power to the non-essential areas. The 2 sections are joined together with a bus coupler inside the panel. The working principle of the power transfer is the same as that of the panel with 2 incomer side. The only difference is the operation of the bus coupler, which is controlled in conjunction with the main incoming breaker. When the main breaker closes, bus coupler will receive the closing signal, and if the main breaker is open, bus coupler also open. Under normal circumstances, the full panel operates with power from the main incoming section and the essential side incoming breaker will be open. When the utility power fails, the incoming and bus coupler breakers open at a time and send a start signal to the generator. Power from the generator reaches the secondary side, breaker close and energizes the essential section of the panel. When the secondary power is live, the main section incoming breaker and bus coupler will be open. The essential side power will be ready within 6 to 8 seconds. When the utility power is restored, the control system checks the stability of power and send a signal to open the secondary breaker and stop the generator. The main incoming breaker will close after the secondary breaker opens and send a command to close the bus coupler. The full panel will be ready with the main power within 10 seconds. We will have a look at the functions of the control circuit of AMF in detail with the live video. The function of the AMF system in a panel with main, secondary, and bus coupler. MSB with 2 incomers and bus coupler, main breaker and bus coupler close with main power. Main power fails. No power in the complete panel. The generator started. Power reaches the secondary side. The secondary breaker is close. Main and bus coupler breaker open. When power restores, secondary breaker open, no power in the complete panel. The main breaker close and after 2 seconds bus coupler will be close. AMF control system. In part 3 we have learned about the basic interlocks provided in the control circuit using PFR. PFR coming with 2 contacts that are normally open and normally close. As shown in the figure, the points L1, L2, L3, and N of the PFR directly connected to the power supply detect the presence of voltage. PFR will be active when the power comes in those points and followed by the contacts associated with will be activated. Normally open contacts of the PFR acting as interlocks in the main and secondary control circuit. More details and settings of PFR shall be available in the controls part. The block diagram explains the interlock. Control supply to the coil of relay K1 connected through normally close contacts of GPFR and relay K2. Control supply will be available to the main breaker only when relay K1 active. That is GPFR and relay K2 should be in the open position to get control supply to the main breaker. The same logic applies to the secondary breaker also. Control supply to the coil of relay K2 connected through normally close contacts of MPFR and relay K1. Control supply will be available to the secondary breaker only when relay K2 active. That is MPFR and relay K1 should be in the open position to get control supply to the secondary breaker. End of part 4. The function of all components and study of control circuit provided in the controls part. Thank you for watching my videos. Subscribe to the channel to get more videos and updates.